So we have quiz on Tuesday. We have our sprint deadline on Sunday. Sprint 4 will be revealed at the end of, probably the very beginning of next week. Just what are the additional requirements beyond what you heard from the client yesterday. Beyond that, I don't think there's a ton. There will be during our finals period, rather than an exam, there will be a very informal required presentation. I'm not even going to do too much grading with that presentation. It's mostly you were here and you did it. And part of that is just going to be to go through what was it like for you to go through this process. You'll present with the team, for those of you who shifted teams, you'll present with the team who you ended on, but you can certainly talk about what that development process was like. You can talk about, I also want to see images that the client requested from you of what your UML looks like, of the underlying representation of your code. I think that's going to be really interesting. And unless you all have been asking each other outside of class, maybe you don't know a ton about the development of the other group's projects and what they look like. So it'll be really interesting to see what are the differences between people's applications, what are the similarities between people's applications. And then I joked about this to the people who were there at the end of the lab period yesterday, but there will also be donuts. Those donuts I joked as coming from the client as payment for everything that you have done. That's not actually going to be the case, but the joke was, this is why you have legal documentation about your project in advance, so you don't get paid in donuts.
I demand at least some Mr. Pitt with my donuts.
And then I had to share this with everyone because it was really funny, but is there anyone here from Swagcraft? No. Excellent. So this will be new to everyone.
Oh, what's going on?
Anyone who's here from the Swagcraft team, the development team, because everyone in that team heard this joke in the client meeting, but no one else was here for it. So Robert asked if he could break the client, I can't English today. Just professionalism for a second to make a joke. So he said, so basically what you want us to do is launch the snipping tool and snip the, and so the answer is no, it's not exactly what we want. We actually want you to take a bigger scale picture. For instance, only part of the UML is currently visible on the screen. We still want that export as an image to capture everything. But he said, yeah, so we just launch the snipping tool and do that. I said, that would be one way to do it. And when I bring donuts for people during our finals period, I'll bring you a snip of a donut and hand it to you. That's the same thing, right? So I'm actually going to do that, I think. I'm going to try to actually make a cardboard cutout of some kind of donut and put the little snip things and hand that to him. So no one should let him know that I'm planning to do that, but I'm going to try to make that happen.
So for the presentation day, how much time we get to present our project?
So we have a 2-hour block
Okay.
of time for the final. So there are 5 groups. So we just divide it. That'd be about 20 minutes. I don't have an expectation that it will take 20 minutes necessarily, but maybe I'll just have someone go through like, here's what it was like in sprint 1. Here's what we learned. Here's what we struggled with. Sprint 2, here's what we learned. Here's what we struggled with. Here's kind of what our application was capable of doing. What was it like for your team or group to go through that so that we can have one final period of learning from each other of what that was like.
You know what that is?
I have not even looked it up.
Is it like?
One of those, so it's Tuesday through Friday, I think this term. One of those days. I can look that up and post it as an announcement.
The picture of the cartoon of the tree requirement, all those things you showed earlier. So that would be something we will bring.
Yeah. And then remember that sprint 4 will be due that Sunday before finals. And then there will be a final code submission that is due at the end of day, I think Friday of finals. You'll have 5 extra days to, regardless of what happened with sprint 4, I'll try to get that turned around as quickly as possible. But you'll have 5 more days to just get more stuff done. And that way, there is half a sprint worth of grade that the final code will be. There are no additional requirements from sprint 4. So yeah, just fixing whatever you can to make this the best project for your code portfolio that you can.
Will that be like an updated sprint 4 grade, say if we like miss some points with functionality or like get usage or whatever, will that be updated if we?
It will not be updated for sprint 4,
we'll
but it would be
extra credit?
shown in the final code submission. So I think 15% of your grade is each sprint,
Mhm.
and then an extra 10%, I think, comes from the final code submission. Something like that. So I'll just regrade everything. Nothing can go down because it's the same version unless something gets horribly, horribly broken that you didn't realize got horribly broken. Don't let that happen.
And then are you expecting every team member to talk in that presentation? So
That would be nice. I do want to hear from everyone. So it'll be basically participation based. I have historically tried to make this a little bit more of a real presentation where I consider things like how professional are you acting? Are you using a bunch of filler words? Are you know what you're talking about throughout the time that you're doing that? But I honestly think that that's a lot to think about during finals week for something that I've asked you to do a lot for the entire course. So it should feel more like a celebration than a high stakes delivery. It's more about what you learned than how you're delivering what you learned. That's the conclusion that I came to. But I think that's what I want to focus on. Other questions or concerns before we dive into a little bit of new content? All right, we're gonna do it. Save that. All right. So the next important part that we're going to cover in the class is going to be related to one of the Sprint 4 requirements that the client did not talk about because the client knows nothing about this concept. But it will be a requirement for your project in the final sprint. So where we are headed is we want the end of this set of workflows. We want to do all of these workflows. We've gone through a lot of these workflows, but as we move through these workflows, we start to automate more and push more and more of the work to the cloud rather than what's happening locally on your machines. So let's talk about, in general, what is continuous integration and how do we think about it? What are the tools for continuous integration? And then what are my expectations for that for our project? So continuous integration in and of itself is the idea of now we're going to start having a place for all of the work to happen remotely. Only the development of something is going to be happening locally on your machine. As soon as you are done with that, as much of the project as possible should be defined remotely and executed remotely. I don't know if I love this concept of a mountain, but we are slowly climbing this mountain from the ease of the bottom to the victory of reaching the summit, I guess. So we started out by locally testing. We wrote some tests. We built the project locally on our machine, and we ran the tests that we wrote locally to ensure that the code as we wrote it on our machines is working. Once we had done all of that, Then we committed the code to GitHub or some other central repository. Once that code is there, then we have been reviewing each other's code, and we just assume that the code works at the remote level. By the time that you are taking a pull request from some other developer, you're going through it yourself, but you're just assuming that if you can't spot the issues, they tested it well enough that it works. So we had the manual inspection of code, manual inspection of the tests that were written for that code. And obviously there could still be bugs, and there are still bugs at the local test level. Moving from this, the next step is to be able to build your project remotely. This is what requires either Maven or Gradle if you're in Java, PyTest if you're, PyTest if you're in Python. So you're building the project on your GitHub. What this means is that if you're capable of running that entire process, that means the tests are stored remotely. You can set up a remote environment to run all the tests. Now, I guess once we do the remote testing, but for remote building, the idea is that we can set the build process to happen remotely. It means you can build and run your application from the web. You still have to go through that same code review process, and you're still trusting that the code works because there's no testing happening remotely. To get remote testing working, sorry, I let people catch up with their notes. I tend to lecture too quickly. Any questions on local testing, remote building? Yeah.
So you mentioned that there is the remote testing for somewhere, not in your location.
Yeah, so you can still locally test. All of those tests are defined as part of your project, but now we're gonna start moving toward putting all of that in GitHub.
So does it mean like, my question is like, if I can, on the GitHub, repository, I can change those tests, right?
If the tests are directly part of the project. So we're gonna link them to a process rather than to the data that's stored as part of the project. And as part of the process, then the tests that have been written, yeah, you don't want to have the ability to modify someone else's tests. So the next step is to test remotely. So we're still going to be automatically building the project on commit. So this says whenever any individual member of the project commits remotely. So whenever you do that final push, then the code is going to be built then and there. Make sure that that build is successful. If errors are reported in the build process, we cannot merge your code into the existing code base. This tells us that at all times, your project is buildable. You will not ever have build errors. Because if any code that you were to commit were to create a build error, that is caught as part of the commit process. If now no errors are reported in the build, now we're going to run all the tests. So the project was able to be built, which means it can be run. If it can be run, it can be tested. All of the tests that have ever been written for the functionality of your project are run now on every commit. This now says, in addition to the build being successful, now we know all of the tests are successful. So not only have you not broken the ability to build your application, you've not broken the ability for any functionality that you are aware of. Note that this power is only as strong as the tests that you have written for your project. If you've written a bunch of garbage tests or not very many tests, then automatically running the test isn't gonna tell you very much. But if you built a very powerful, strong testing suite for your project, you can be reasonably sure that your functionality at least has no major flaws whenever you commit changes to it. If any one of those tests does not pass, we don't merge. So you get feedback that says, here are the tests that failed. You don't now have to run all of the tests, have the most updated tests locally on your machine and run all of those tests. Just like it makes a lot of sense for your fellow developers to push code to a remote repository. It makes sense for you to push the tests that you write for the code that you're developing to those remote servers so that you make sure that someone else who's developing some other piece of code doesn't accidentally break some piece of your code that you've written, because now you have a test that is written for your code. If their code breaks your code and a test that you've written for your code, now their code is rejected until they pass the test that you wrote for your code. So that's an extra level of security on your code so that your fellow developers don't botch things. So here's kind of what this process looks like. So the developer works locally on their machine. All they do now is commit. This commit will be new code and new tests for the code that they just wrote. The repository now is going to run some CI server. This is going to be some kind of probably, what do we want to call it? Yeah, I think of the term. Self-contained OS environment.
You're talking about the GitHub Actions?
That is how we're gonna do it, but it is, oh my gosh, what's it called? What's it called? Container. There we go. Done on a container. So have people heard of the concept of a container before? A few people. It's just a bare bones OS environment. So you can imagine having there's no applications installed. It only has the bare bones software that you need to be able to execute a very particular kind of environment. So you can imagine stripping Linux of everything except the ability to boot, the ability to, you have your language, Java installed, you have a Java runtime environment, and then you have the ability to run JUnit tests. That's it. Any dependencies that you need for your project, those are installed, and that's it. Literally nothing else. You don't even have something like an editor. There's no text editor installed. So there can be very few reasons why something would not run. There are no conflicts that are not necessary conflicts for your project. So that is the concept of a container. So this CI server is one of those containers that is just meant, the entire purpose of its existence is to build and run your code. It does nothing else. So it will interface with Git. It needs to be able to, so it probably has Git installed. It clones your repository, checks out the current branch that was being committed to, builds the project, however the project is determined to be built, and then it will run the tests. If the build fails, it tells the Git server the build failed, which it then tells you something about your commit broke the build process. If that's not true, then it runs the tests. If all the tests pass, then the code is committed. If the tests fail, then the server routes back to you some message that says, you broke a test with your commit. Here are the tests that failed.
Plus.
But the idea is you don't have to run this yourself on your own machine. You don't have to worry about any of those conflicts. The CI server does this automatically, and the communication has nothing to do with the developer's machine either. So it interfaces directly with what's on Git. Does that process make sense? Do people see why this is important? How it can save time and headache once it's been set up? Yeah,
That's how they are gonna set it up in the real world.
yes.
Okay.
And that's how we're gonna set it up via GitHub Actions for sprint 4 of this project. We don't need to make the container for this. GitHub Actions will handle all of the CI server. It's just a bunch of settings. So you can set this up. It's just, it'll create it for you. So how do we go through this, and what does the actual development process look like in a continuous integration world? A lot of this is going to sound like what you've already been doing and review. We're just going to add a little bit at the very end of it. We've already done this. We have a code repository. We have our code up on GitHub. We've been committing on feature branches, adhering to Git flow. When we merge those feature branches into dev to become the best working project with all the features that we've implemented so far, we merge, deal with any merge conflicts, and update dev. At the end of every sprint, we release the current version of the product, which is what we've been doing at the end of each of our sprints. So a code repository helps with this process. Step 2, automate the building process. We did this early in our project as well. So Maven, Gradle, or PyBuilder for people who are in this class. So you want to use some kind of build system or framework. Make sure that the build process is defined and can be built automatically. So single command to be invoked for the entire project. Fewer steps, lower likelihood of errors in the build process. Great. Grade. Done a day already. Now we want to automate the tests. So our code should be able to test itself. We need to make the tests. We adopt some kind of testing framework, and then we want to be able to, with our build, link all of our tests to that. So you can do something like Gradle test. This runs all of the tests associated with the build of your project. So this is something that we need to do. We need to at least be able to link those tests to the building process. We then need that container, that test environment. So this needs to be some kind of configuration. The important part here is that it's reproducible. So the only things that it needs to be able to do, download the repository, build the project, run the tests, send some feedback about whether the build was successful, whether all the tests were successful. Then the final one, because this process can actually end up taking quite a while, we want to make sure that this entire process is as fast as possible. So there are 2 measurements that we can take for that. The latency, the end-to-end time, so communication between your development machine and the GitHub server and the CI server back to Git, back to your machine needs to be as fast as possible. Then the throughput. So what happens if you're trying to build multiple projects at the same time? What happens if you are, so you want to make sure that as much can happen as fast as possible. You want that build to be as fast as possible, but also thorough enough that the tests get run. Finally, we use GitHub Actions to trigger the build from a commit. Now, after all of that has been set up, on the commit, we're going to go through the entire build process. We're just going to communicate that to the CI server. The CI server is going to go through the build. The build is going to run the tests as part of the build, and then feed that information back to you. So we just need that hook or that action that GitHub Actions will provide for us that says, when you commit, do the build, run the build. As part of this, there will be an option that allows you to just force all of this to pass. The build must succeed and the test must pass before you are able to commit or merge. So your code must have been built and all checks done prior to merging into the existing code. So the project must build, the test must pass. Some additional ones that are common is the code coverage didn't decrease. That makes it impossible to commit code that hasn't been tested as thoroughly as the rest of your code. So I'm developing some feature. If I only write enough tests to get 50% statement coverage over what I just produced, and the project as overall has 80% statement coverage, then my commit would decrease the code coverage. That tells me that I need to write more tests about the code that I just wrote in order to interface it with the project so that our code coverage measures don't decrease. You can also add some style checks. This is just logic, a program, a script that will run the committed code and look for any particular style no-nos. So maybe we want there to be spaces between every equals or plus, or that there is a Java doc comment before every method, or that there is any kind of style that you might care about for your code. You could attach some scripts that say, make sure that these scripts run to completion and accept the code before we merge that code into the project. So larger scale companies have all of this to make sure that the code that you add to the project is to the project's standard. Questions on this 7-step process?
That seems to be very detailed
Yes,
and been controlled.
yes. Yeah, that is the idea. Coding can be very uncontrolled, and I'm sure all of you have experience with the uncontrolled part of coding. And it makes it very scary when a company with legal and ethical requirements hires you. They don't really know who you are. They don't really know if you're going to care enough about what you do. So these checks need to be in place so that they don't get sued. So here's an example of a screenshot from Travis CI, another continuous iteration tool. The more important one for us, since everyone's doing their projects on GitHub, is to use GitHub Actions. So there's a config file for this. .github/workflows/something.yaml gives you all the configuration files that you'll want for configuring your actions. Then you will also be able to describe and write these files within that. So you can see that here are all the markdown files, CI with Maven, etc., commit push by. So we're going to be using GitHub Actions for this. I'll take a little bit of time during our next lab period to explore this with you. So this isn't required until Sprint 4. This is not something you need to worry about until next week. But when we start it next week, we'll actually go explore GitHub Actions and see this working. So you can also augment your pull request checks with this. We can now see that merging is blocked because it hasn't been reviewed. You can add additional blocks to the merge process now based on these actions. We can say this action must succeed, otherwise merging is blocked. This action must succeed, otherwise merging is blocked. So you can now define any of these actions. Build must succeed, test must succeed, any scripts looking over the style of your code must succeed, otherwise merging is blocked. So to summarize this, what's required for the upcoming sprint? CI for the project. I will force us to be using GitHub Actions for this rather than Travis CI. You must be able to automatically build your project. You must be able to automatically run all tests associated with your project. And this schedule a meeting with the project manager. We're gonna do all of this during our lab period next week. Finally, for code coverage, there is going to be an additional requirement for code coverage for your model. Required for this last sprint, you must have 90% model statement code coverage for the sprint, which means you need to have written enough tests that 90% of the statements in your model have some test that executes that statement. There are also some tools within GitHub for this. This is another thing we will talk about in the lab meeting for next week. So how do you actually go implement those tools and get the ability to now visualize what your code coverage level is in certain files of your code? You can also dedicate some chunks of your code to say all of these files together is the label model. So then you can get the code coverage for all of those files together to display whatever value you want. Questions on continuous integration? So if you ever hear the term CSCD, that stands for continuous integration, continuous development, that's talking about this idea. It's very useful in interviewing settings to be able to talk about that or interface with that idea. Questions before we have a brief introduction to APIs? Start getting that up while people think if they have any questions. Okay. API design. First of all, what's an API? Anyone want to describe what an API is to the best of your understanding? We've interfaced a lot with them over the course of the courses we've taken at this institution.
Programming interface.
2/3 correct.
Application.
Yes, application programming interface. A lot of them are pretty advanced. What is it? So that's the term. What is an API?
Right, that using the word in of itself.
Right.
Is the biggest problem.
Yeah.
I understand, is the way to allow one application to be,
Okay, sure.
so like, my front end database backend.
Yeah.
Dedicated method that I can call.
So it's the publicly facing aspects of code tools. So for instance, maybe we want to embed Google Maps into our web page. We would be using Google Maps API to be able to do that because they've written code that says this is something that someone else can do. Think of it as all of the public methods in the usability of someone's application. Eventually, you're going to be making an application that is big enough that either some other application that you're writing or someone else is going to want to interface with it. Before you actually sit down and start writing that code, you need to think about what is it going to be like from an outside perspective to interface with your code. That's why designing an API is really important. The other is that once your code goes live, what happens if you decide to refactor your code and change how some of your methods are called?
So people can read that and see how to work with and use.
What if I've already been working with it? What if I built a web page that has Google Maps embedded in it for the last 3 years? What happens when suddenly we try to call that method and it's not what that method expects anymore?
I care non-profit.
If the API changes, everyone who's using it and expecting it to be what it was stops working.
Then you need to tell people.
I wouldn't even go that, as soon as you change your API, the entire world hates you. So what is it? It's an application programming interface. It's every way that you can interface with an existing software system for externally? How is your system meant to be interfaced with from the outside? What tools do you want to create that other people can use as part of their tools? So Google Maps is a great example of this because it is a big tool in and of itself. It can be used for a bunch of other tools for a bunch of other purposes. So they allow public interfacing with that so that Google Maps becomes the standard whenever you want to embed a map into any application that wants to use a map. How do you get a bunch of money? By designing something that everyone wants to use because it is that good. You could then license your API. You could say, pay me some amount of money per month, and I will let you use the public interfacing tools that I have created. Does anyone have access to Google Maps source code when they plug an API for the map into their web page? No. If Google decides to change things or revoke it, that functionality is gone. That means you can charge for it. You pay me per month and I won't revoke your access. So from a company view, if your API is well designed, it's very easy to use. It can be very intuitive. It can also, if you design a poor API, can be an absolute nightmare to use. The usability of your application is gated by the usability of your API. I don't care how fast your program runs. If when I'm trying to use your tools, I have to scour your API for how to make every single call, and it takes in a bunch of parameters that I don't understand why you're using. And it's just not necessary from my view. It's gonna make it a pain to use your tool. I'm not gonna wanna do it. Even if it's bleeding edge fast. If your API is public facing, as it says down here at the bottom, you get one chance to get it right, which means that the design is very important. If you get it wrong, you're going to break everyone's code in order to get it right. Or you just have to deal with the fact that everyone who ever uses your system is going to be mad at you for the decisions that you made. So what does a good API look like? Good is a terrible term here, but what are the characteristics of an API that people will want to use? It's simple. What do we mean by simple?
Like plug and play.
Yeah, it should be something that is easy to adopt. Easy to learn, discoverable. That means if I want to call a method, that method is named something that I would think of.
Use.
That functionality that I want to interface with. It should be, if I were writing this, oh yeah, of course it's that name that takes those parameters. That's exactly how I would write it. It's hard to misuse where I think I'm doing X, but I'm actually doing Y. Then when I'm making my own application that uses your application, have to go debug, but I don't have access to your source code. So I have to try to understand in a black box setting what your code is doing in a method called, maybe it's called add4. I pass in 6 and it returns -6. What happened? Who knows? I don't have access to your code. I can't figure it out. It's hard to misuse, meaning I don't want my program to crash through the use of your API. It's consistent, so terminology needs to be consistent across multiple different calls. Maybe you have 2 different methods that take the same information. In your API, you might call one of them person1, and in another you might call it entity1. So your API needs to be consistent across the types of terminology that you're using so that when people go to read the API, it's more understandable. It's well documented. So again, I don't have access to the underlying code. So I need to, from just the description of your API, I need to 100% understand what it does. Because you don't get the how it does it. You just get the what it does. That communication must be crystal clear. Needs to be powerful enough to satisfy the requirements. I want to use your application to do what I want it to do. So your API needs to have the functionality for me to be able to do that. Easy to extend. As you go develop more features in your application, you should be adding to your API, but not going back and changing the existing API. So think about the extendability of your API as you go to add the functionality for what you're going to eventually plan to add to it. And of course, it has to be appropriate for your audience. So those are some characteristics of good APIs. How do you go about the actual design process? Just like designing code, we're going to go through a very similar process for designing an API. We need to know the requirements. What does our software system need to be able to do from an outside perspective? So you don't want to go gather the solutions necessarily. We want to go figure out what interactions does the outside world need to have with this code. It could also be the outside world being other aspects of this code that we're eventually going to write. From here, you make your scenarios about how and when they're going to be used from certain application perspectives. You'll write a short specification document. You can consult with some end users if you have access to those to determine whether that specification is going to lead to the requirements that they need. And over time, you will flesh out that spec. As with code, there's no way to know 100% when you sit down and start what it's going to look like at the very end. So you build in the ability for it to evolve over time. We will come back to this on Monday. I don't think we're doing anything terribly important other than lecture on Monday. So I think Monday will be the time that we finish this off. And we will finish talking about this.
Are we doing the exam review or the quiz review?
I will spend some time on that, yes. My goal will be to get through this. I'll probably start with the review. As we run out of time, or as we run out of questions, I'll dive back into this. But yeah, I'll certainly take questions on Monday for the quiz review. Questions or concerns about where we are, where we're headed in the class? Yeah.
Study guide already posted?
Not yet. I'm going to do that as soon as I get back to my office.
Okay.
If it's not posted in a few hours, somebody send me an angry email.
Make sure to chat GPT will send it to you.
Yes. Yes. All right. I said this as much as I could yesterday, but continuing, great job on everything for the project. It's really coming together. I can see it from every single team that you put a ton of effort into this and it shows. So I know it's been a ton of work, but I am incredibly proud, and I think you should be incredibly proud of the work that you put into it and the results that are really starting to show. So keep it up. Have a great weekend. I'll see you next week.
Will you later? Are you need more time?